All right, now can you hear? On Zoom? Yes, yay, okay. So there are a couple of things that I want to cover before we start covering material. And the first thing is I want to talk to you about the clicker app. So some people were not able to do the clicker, the handheld clicker, right? Some people had problems with that. If you have a handheld clicker, you should be able to use it. But what I didn't know is that I needed to add what's called a course block, and then you need to add your clicker to my class. So if you go to your Moodle page, I'm showing you on the screen, go to your Moodle page and click on this course blocks right here. It drops down and you should see something that says iClicker, and then you click student registration. And you should be able to register your handheld clicker, okay? Questions about that? Anybody? Okay, so if you cannot get your handheld clicker to work, starting on next Tuesday, you're gonna start losing some points. So if you have clicker problems, we need to get them sorted this week. So those who had handheld clickers, that should solve your problem. If you have not gotten the iClicker Reef app, if you want to do the app on your phone or your computer or whatever it is, you need to get it figured out before Tuesday. So if you need some help to figure it out, let me know. But some people said, I just didn't get it yet, things like that. So please make sure that you get that figured out. Okay, let's see. What else? Like I have a list of things I want to talk to y'all about. So for yesterday's class, not yesterday's, Tuesday's class, I went in, all those people who had iClicker problems, who put me a note in the Excel spreadsheet over here, I fixed your stuff. So you don't look like you were absent anymore. You look like you answered everything, that kind of stuff. So if you had problems, I tried to fix you. If you didn't get fixed and you had left me a note, please send me an email and let me know, hey, Dr. B, you didn't quite get me fixed, and whatever it is, okay? If you have problems today, you need to fill in this spreadsheet. This is the last day I'm gonna have a spreadsheet. So put in all of the information in every single column if you have a problem. Some people put me partial information and I can't fix the problem if I don't have all the information. So there should be something in all of these columns. Make sure they are all full if you need to use it today. Okay, let's see. What else? Oh, if you are on Zoom, you need to make sure that you are using your complete first and last name. That goes for everybody, right? So you can all join Zoom right now in class so that you can communicate on the chat, but please make sure that you put your whole first and last name. Sometimes people leave me things in the Zoom chat. Hey, Dr. B, I need help with something. I always go through the chat after class, but if you have some strange name, it's not your first and last name, I don't know who it is, okay? So please use your whole first and last name. All right, let's see, what's next? Oh, homework. So the mini homework, the first mini homework was due last night, right? A lot of people had some technical issues and things going on, and the bookstore ran out of books and all that kind of stuff. So I extended it until this Friday because you can get online and you can get a free 14-day trial of the homework, the Mastering Chemistry homework. So if you have not gotten an account yet, you need to go and do that today. Questions about that? Let's see if I left anything. Anybody on the chat? The spreadsheet for oh, it's wrong. Okay, just put it in the one, it says the spreadsheet's wrong. Just put it in the one that says 4T. It's fine. Okay, let's see. There were two questions that were emailed to me that, that I kind of wanted to talk about in class. The first one was, should I read my book? Yes. Yes, if we're working on chapter 1, you should be reading chapter 1. I'm not going to assign you reading. I'm not going to tell you these pages to those pages, but we're going through the book. So the book is another resource for you. Read it. They have really great examples where they walk you through different problems and things like that. And sometimes just having somebody else, even if it's the textbook, somebody else go through it and do it, it's going to help you. And if you got the ebook, they even have videos embedded inside of the ebook. So sometimes they'll like go through a problem step by step, like I would do on a tutorial, but it's somebody else. And sometimes that's nice. Sometimes you just get it just with somebody else doing it. All right, and the last one was, do we need to memorize units? Because if you watch the video, we did a lot of conversions in that video, right? There are a lot. Do you have to memorize them all? No, no. I'll tell you, the ones you do have to memorize are the metric units. Like you have to know micro means 10 to the minus 3, right? You need to know the metric units. Every other conversion I'm going to provide to you. So you might want to jot that down right now. I will give you every other conversion factor except for metric units. And if you look in your textbook, if you got a hard copy of your textbook and you open the back cover, there's all kinds of unit conversions, all kinds of tables. It's a really good resource. And in the middle, there's one table that's metric, and that's the one you need to know. So in the inside cover of your textbook. And I don't really know how it is on the ebook, but it must be there on the ebook somewhere. Okay, the spreadsheet is on view only. Oh, okay, let's see. That's a good point. Change. Edit. Apparently when you copy them, it doesn't copy the permissions. Okay, permissions should be updated. Thank you. Okay. Any other questions? Yes, ma'am. It would help. So if you have a question, you can communicate. I'm not taking roll that way, so it's not going to hurt you. So like if you just kind of keep trying, you know. I think we're going to be dealing with that issue all semester long. I hate to say that. But if you have a question, try to jump in. If not, just throw your hand up and speak loudly and I'll do the best I can. And I'll repeat your question, which I should have repeated it, which was that the Wi-Fi sucks. Okay. All right, so we ready to do some actual chemistry today? I'm gonna try this new, when am I gonna do an iClicker attendance? I'm gonna do it right now. Let's see. I'm gonna do it right now. This one, and we're gonna do attendance right now. So this is what I'll always do every class period. I kind of just wanted to take care of those little details. Oh, I can't. Can I please repeat the part? Let's see. About the clicker. So if you have a handheld clicker, you have to do the Moodle course block up, down. Let's see. There it is. You have to click that to find your, what do you set your physical? I don't know what you set the physical frequency to. There is an iClicker base. I don't know what it's set on. It doesn't say. I know, I haven't done it yet. Right? Okay. So that's all about the handheld clickers. Try the different frequencies. I don't know which frequency. And what video were you talking about when you said there were a lot of conversions? The sections 4, 5, and 6, we did a lot of conversions, and we'll do them today too. So we'll get to that. Okay, let me go back to attendance. Let me minimize this real quick. And then I need to see my cloud. Did the class end? We'll try it. If I need to go in and clean up the attendance, we can. No big deal. Okay, so now it should stay up. Good. All right, so here we go. iClicker attendance. I am A, present in the classroom, or B, remote at home. So go ahead and try to click in. If you have the app, yeah, if you have the app, you don't have to worry about the Moodle stuff. The Moodle stuff was just for people who have the yellow remote control. Yep. Okay. I know we have more than 75. So if you can't log in right now, you're going to the Excel spreadsheet and you're entering the information into the Excel spreadsheet. Okay? All right, so I'm gonna go ahead and end it.
I can't write on the sheet.
You can't write on the sheet. Go to the other one. Go to the one that actually says 5T. It's actually 4T. And you should be able to write on that one because I changed the permissions because that's the one that's actually 4T. Okay. All right, so we're gonna switch over. Minimize this. Okay. So the last thing we were doing in class, and if I could pull up the chat, I'd like that. Where's my chat? There it is. Okay. Okay, so the frequency AA works best for someone. I don't know what it means when it says no base because there's a base here. So I don't know. You might just want to try the Reef app. I don't know. Okay. So somebody keep an eye out on the chat for me. But let's dig into some chemistry. All right, so let's see. I can do this. All right. So we were balancing equations last time we were here, right? So we want to be able to practice this and we want to be able to do this very well, very easily. So everybody has this, the in-class problems, they're really from your textbook. I just stole them. So this first reactant, what could we abbreviate that as? Right, I'm learning this new thing. X2, so let's call the other one Y. Do we need to put anything? Nope, because it's just one. Yields what? We only have one gray one, so the gray is X, the red are Y. So we have X, Y2. So how are we going to balance that? What I like to do is I like to put down the bottom. I like to say, okay, how many X's do I have? I have 2. How many Y's do I have? I have 1. And I do the exact same order on the other side. X, I have only 1. Y, I have 2. So what am I going to do? What do I need to do? I don't have enough X over here. So how do I get enough X? Multiply by 2. So if I put a 2 here, I definitely now have 2 X's, but how many Y's do I have? 4, because it happened to both of them. Am I balanced? No, I'm not. So I have my X's are fine. How about my Y's? Y's are not. I need to multiply by 4 to get 4. So in this case, we're going to put a 1 here just to show that we know that there's only 1, but we don't usually do that. Okay. No, if I wanted you to write this balanced chemical equation, that's a great question. What would you actually write? I would write x2 plus 4y yields 2xy2. That would be the real balanced formula. It's a good question. Okay, let's try another one. Now we have 4 different kinds of atoms here, right? So we'll call this X, we'll call this Y, we'll call this A, we'll call this B, right? And we're not going to have colors on the test, but this is what they have. So now what happened? What did we make in the products? We have the dark gray, which is X. We have the red, which is A, the light gray, which is Y, and the green, which is B. How many X's do we have in the reactants? 1. How many Y's? A's, B's. Woo. Okay, on the products, X's, Y's, A's, B's. Yay, we're so happy. We didn't have to balance anything. That can't be a good sound. The computer's making some noises. All right, so let's try one that's not quite that easy, right? All right, so add coefficients and balance the equation shown. So let's write our elements out. We have aluminum and we have chlorine in this one. So aluminum, and I like to write them in the same order so I don't get kind of mixed up. So how many aluminum in the reactants? 1. How many chlorine? 2. And on the other side, we have 1 aluminum and 3 chlorine. So what's not balanced? My chlorines aren't balanced, so I'm going to have to balance them. Can I multiply 2 by anything and get 3? So I'll tell you a trick. The trick is multiply it by each other, right? So multiply 3 times 2 and 2 times 3. And what are you going to get? In both cases, 6. So be careful to put the right coefficients in the right places, though. And this one was 3. Are we balanced? What did I not do? I have to worry about my aluminum over here. So what am I going to do? I'm going to multiply by 2 because I have a coefficient. So I get 2 here, so then I have to put a 2 here. So now I'm good. Yeah. All right, let's keep going. Rocking and rolling. Let's do another one. We have hydrogen, we have chlorine, and we have zinc. Okay, so let's do the same thing over here. Hydrogen, chlorine, zinc. In the reactants, how many hydrogen? 1. How many chlorine? 1. How many zinc? 1. On the products, we have 1 zinc, we have 2 chlorine, and we have 2 hydrogen. So in this case, we have 2 that we need to worry about. So which one should we do first? It doesn't really matter. Doesn't really matter. You could pick either one. So let's do chlorine. So chlorine, I need to multiply by 2, right? So I'm going to put my coefficient, but what happened when I did that? I need to multiply hydrogen by 2. Am I good? Yeah. Okay, questions? All right. Okay, let's do the next one. Did y'all have enough time to copy? Am I okay? Y'all know to just like kind of holler at me? It's all good? Okay. So SiOC. Okay. So silicon, how many in the reactants? 1. Oxygen. Carbon. Now product side, silicon. Oxygen. 1. Carbon. 2. Be careful. Make sure you check all of them. That's a way that that's a place that you can get tripped up a little bit. Okay. So my suggestion is to balance the oxygens first, right? Because you have carbon in multiple places. It's easier to balance when you pick the thing that's only in one reactant or product, right? And we only have oxygen in one place on either side. So that's where I would kind of start with. Okay, so what are we going to do? We have CO, so we need to increase our amount of oxygen. So we're going to multiply by 2. So we're going to put a 2 here, right? And then what? That changed our carbon. Our carbon, now you can't really just multiply here because it's in 2 places. So you have to say 1 plus 2. Now we have 3. So be careful about that. Now what? If I just stick a 3 in front of carbon, it's really nice because it doesn't affect anything else. So now I am good. Thank you. Okay, are the Zoom recordings going to go on Moodle? Yes, they're going to go on my YouTube site, and my YouTube site is linked on the Moodle homepage. Oh, that's something I did want to tell y'all real quick. I put an extra link because some people were having a hard time finding the videos. So I put an extra link for all of the videos. So this takes you to the YouTube playlist for all of the pre-recorded videos for the entire year. This takes you to the playlist for all of the 14 recorded classes for the whole year at the very top of the Moodle page. I hope that helps. So you don't have to dig around for it. I'm trying. If y'all tell me something's not good, I'm gonna try and fix it. Okay. Thank y'all for monitoring the chat for me. I appreciate that. Okay, so let's do another one. And they get tougher as we go down. So nitrogen, oxygen, hydrogen. Nitrogen, oxygen, hydrogen. What do we have? 1 nitrogen. How many oxygens? 3. 2 here, 1 here. Hydrogen, 2. Okay, products. Nitrogen, 2. 1, 2. Oxygen, 4. Hydrogen, 1. Okay, where do we want to start? I'm telling you, don't start with oxygen. It's everywhere. What should we start with? I would start with hydrogen. So let's try that. What are we going to do to hydrogen? We're going to bring this one up. So we're going to do what? Multiply by 2. Okay, so I put my 2 up here. And what happens? I changed a bunch of stuff, didn't I? So my nitrogen, I now have I now have 3 because I have two here and 1 here. Okay, and then oxygen, same thing. 2 times 3 is 6, plus 1 is 7. Okay, now what? Am I balanced? Absolutely not. Absolutely not. Okay, now what? I could balance the nitrogens. Okay, so what are we going to do? So we want to bring the nitrogen up to 3. So we're going to put a 3 in front of it. So now our nitrogens work, but now we got to worry about oxygen. So our oxygen, now we have 3 times 2 is 6, plus 1 is 7. Now are we good? Very nice. See how they get a little more complicated as we go? I think we got 2 left, right? Yep, just 2 left on balancing. Okay, let's go again. So we got nitrogen, hydrogen, oxygen. Nitrogen, hydrogen, oxygen. Reactants, what do we have? 1 nitrogen, 3 hydrogens, and 2 oxygen. Products, 2 nitrogen, 2 hydrogen, and 1 oxygen. Where we want to start? We can start with the nitrogen. That's a good place to start. Okay, so we want to bring this one up. Excuse me, we want to bring this one up. We get a 2, but what else did we do? We changed our hydrogen. Our hydrogen is multiplied by 3 now. What do we get? By 2, thank you. By 2. By 2. What do we get? 6. Okay, now what? Our nitrogens are good, but our hydrogen and our oxygen are still not good. So let's try hydrogen. If we multiply 2 times 3, we're going to get 6. So if we put a 3 there, what happens to the oxygen? Now we get 3. Oh, that's not good. Now what? What are we going to do? What if, instead of multiplying by 3, what if we multiplied 3 by 2, right? What will we get? 6. Can we balance that on this end? So, oh, and what happened to our hydrogen, by the way? So if this becomes 6, what happens to our hydrogen? So now we have 2 times 6, so now we have 12. What can we do on the other side? So if we change this to a 4, right? What do we get? 12. So we change this to a 4. What happens to our what happened to our nitrogen? 1 times 4 is 4. Okay, now what? A 2 in front of nitrogen, so times 2 is equal to 4. Oh, we're getting close. What's left? If we multiply by 3, we get 6. So see how it gets a little bit more challenging as you go along? But if you just keep working at it, you're gonna get it. And if you get too frustrated, like pull out a new sheet of paper and start with a different element. That's usually a good way. If you get stuck, stop, like crumple that sheet of paper up, write your equation again, and start with a different element. Like start trying to balance with a different element. Don't keep trying to do exactly the same thing again. I don't understand the question.
Okay, like the 2 that you multiplied to that 3 on H2O, right? That was from the 2 on the oxygen.
Why did we do the 2? Because we got a 3 here, we were getting 3, and 3 and 2 is not going to work. right? But what is 3 times 2? 6. So it's really similar to what we did. Where was that? Wasn't this one? Which one was it? Where we multiplied by the opposite. 3 and 2 and 2 and 3. Here, this one right here. No, not that one. We did it up here. Here, this one right here. It's the same trick. Okay. All right, now I'm telling you, this one's a little bit of a challenge. Okay, so let's start. Carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Reactants, 7 carbon, hydrogen, 16, oxygen, 2. Products, carbon, 1, oxygen, be careful, I'm doing hydrogen first, I'm sorry. Hydrogen's 2, oxygen, be careful, is 3. All right, what do we want to start with? What is that? What are we starting with? Why did somebody say carbon? That's right. Why did somebody say carbon? Well, it's only in one reactant and one product. So that's a really great place to start. You want to have a good method when you're doing this. And that's really important to start with something that's easier to balance, right? Okay, so what are we going to do? How are we going to make it balance? Multiply by 7. Awesome. Okay. Let me erase this so that we can see our coefficients. Okay, so we're going to put a 7 there. Now what? What happened? What do we do to oxygen? We raised it up to 21. All right, now what? Do we have 21 oxygens on the other side? No, we don't. We really, really don't. How could we get 21 oxygens? Okay, so what do we want to do? Multiply what? You want to multiply the H2O by what? By, say it a little bit louder. 7. Oh, I'm doing this wrong, y'all. Y'all. Wait, look. We got 7 times 2 is 14, plus 1, 15. Yes. Okay, now what? Can we try to work on our hydrogens? What can we do to our hydrogens? Multiply it by 8. Okay, so if we put a coefficient there of 8, what do we get? 16, but then what do we do to our oxygens? Now we got to change that again, right? So we still have the 14, but then what's 14 plus 8? 22. Okay, now what can we do? By 11. 22. Y'all did so good. Yay. He looks mad. That's terrible. Don't look at that. Okay? Oh, thank you. What do we got? Why isn't it 15 plus 8? Because we had 7 times 2 here. So 7 times 2, right, is 14. And then when we only had a 1 in front of here, that was 14 plus 1. But we now had 7 times 2 plus 8 times 1, right? And so that's what gave us 22. Make sense? Yes.
The way I did it, I had to a lot more complicated things to simplify. So what did you do?
You went, what order element did you go?
I think we did, what did we do? Carbon, then we did oxygen, then we did hydrogen. Yeah, the order of elements does make a difference. You will get there in the end. Now, let me, that's a really good point to make. What if I had something that had coefficients of 3, 6, not plus, yields 9? I have to reduce. Technically the ratio is correct, but I need to reduce. What are they all divisible by? 3. So 3 divided by 3 is 1, 6 divided by 3 is 2, 9 divided by 3 is 3. So those are my real coefficients. So just be careful. If you go down a really long road and end up with some really big coefficients, one thing to check is, do I need to reduce them? Because a lot of times the answer is yes. Okay? All right. So then we're going to switch back. I did a different one on that one so that we could easily write on it. And then I have our regular one here. This is what we were working on. Okay. So when y'all were watching the video, did y'all like my little United States of America little thing about significant figures? I find that you could read all the rules and you can try and memorize all those rules. But if you remember this little mnemonic thing, it's so much simpler, right? So the mnemonic goes, right? It's the United States of America, and you have to know your oceans. So on one side, we have the Pacific Ocean, right? The Pacific Ocean, and we have the Atlantic. I guess you have to know a little bit of geography, but that's okay, right? And what does that P and that A stands for? It stands for, is the decimal present or is the decimal absent? And everybody loves the United States, right? So everybody's trying to get into the United States. So that's what you have to remember for this mnemonic, right? You don't have to remember 10,000 rules. I hate memorizing rules. I hate that, okay? So as long as you know if the decimal is present or absent, you know where to draw your arrows to eliminate non-significant zeros. So let's do some that I didn't do in the video. In A, is my decimal present or absent? My decimal is present, so what direction do I go? If it's present, I go this way. If it's absent, I go the opposite, okay? So if the decimal is present, I'm gonna take my little arrow and I'm gonna eliminate zeros until I get to my first non-zero number. My first non-zero number is a 6. So how many significant figures do I have? Only 2. Isn't that nice and easy? Okay, B, present or absent? Absent. Draw your arrow until you get to your first non-zero. How many significant figures? 1. And I just abbreviate that SF, sig figs. Okay, how about C, present or absent? Absent. How many significant figures? 5. Okay, D, present or absent? Present, so I'm coming in this way. Oh, my very first number is significant, so they're all significant. So how many? Y'all like that? Kind of neat. All right, let's see. All right, now complete each of the calculations and give your answer to the correct number of significant figures. Remind me, what is the rule if I am multiplying or dividing? Your answer is equal to the number of the lowest, I guess, number of significant figures, right? If I'm multiplying or dividing. If I add or subtract, what's the rule? My answer is the lowest number of places past the decimal. So what are we doing in A? We're dividing. So what is, before I do the calculation, what's my lowest number of significant figures? 2. So my answer has to be in 2 significant figures. So if you put this in the calculator, what do you get? You should bring a calculator to class. You'll need it. If you just stuck it in your calculator, read me what your calculator would say. Somebody. 3.5416. You get 3 point what? Just 3.4? Oh, so at the end of class, there's a setting on your calculator. I'll show you, okay? All right, but that's not right. I have to do 2 significant figures. So be careful when you're rounding. If it's a 5 or greater, you're gonna round up. If it's 4 or less, you just drop it off. So the answer should be 3.5. Okay, how many significant figures should I have in B? Be careful. I asked that tricky. I was tricky. I'm sorry, I was tricky. It's not really significant figures. What is it really? It should be one place past the decimal. You know, I actually do try to be tricky a little bit in class so that I can't trick you on an exam, right? Nobody wants to be tricked on an exam. So you get 43.305. But can your answer be more precise than your least precise initial value? It can't. So your answer has to be one place past the decimal, 43.3. Just because you put it into the calculator doesn't mean you got more precision. But your calculator doesn't understand that. Your brain does, because you are super smart. Okay, sig figs in C. 2 here, and how many in the first number? 2. Because we come in, decimals present, we come in and eliminate all those zeros. So what do we get? 0.0715. So what do? These are only 2 significant figures, so we need to round. So what are we going to do? We're going to round up to the 2. The next one is subtraction. So what do? We look at number of places past the decimal. So here we're at 3 places past the decimal. Okay, what do you get? 0.037. Is that what everybody else got? Okay. All right. Now here we come to some of these conversion factors, right? So I tried to do only the odds on the video so that we could do the evens. And look, I even wrote in spaces where I wasn't supposed to write, but that's okay. All right, on average, an adult's lung volume is 5 liters. Convert that to milliliters. Is this something you would have to be able to do without having a table? Yes, this is one to memorize, right? Because this is metric. Okay, so what do? We set up a conversion. And you could do it either way. You could do 5 liters times and then do your conversion, or you could do it like fence post. I tend to do fence post, where it's one big line and I put as many as I need, but it doesn't matter. Okay, so what are we going to do to make sure that that liters gets canceled and converted to milliliters? I got to put it on the bottom. So I know I need milliliters on top. Do we know how many milliliters are in a liter? There are 1,000 milliliters in 1 liter, because milli is 10 to the -3. So a milliliter is tiny compared to a liter, right? Think a liter of Coke. That's a lot of Coke, right? But a milliliter is just a teeny tiny amount. It's a cc, right? You've seen that on syringes, 1 cc. That's a small volume, but a liter is huge. So just kind of keep those in mind when you're thinking about, well, is that more or less than 1? You can kind of keep that in mind. So what do you get? Simply 5,000 milliliters. Significant figures? We okay on sig figs? We are, because these are non-significant zeros. So we really only have one significant figure, and that's what we really started out with. So we're good. Okay. Write scientific notation. So when we're doing scientific notation, our whole goal is to get something that looks like this. A coefficient times 10 raised to some number. But what's the deal with this coefficient? There's something special about it. It has to be between 1 and 10. So how can you move your decimal place to make A have a number between 1 and 10? Where do we want it to end up? Right there, that's where we want it to end up. So what I do is I just count my jumps. I say, okay, my decimal starting here, and I'm gonna count my jumps. 1, 2, 3, 4, 5, 6. So 1, oh, I thought I erased. 1 times 10 to the 4, right? 1 times 10 to the 4, that's why I erased it. 1.4 times 10 to the what? How do you know it was 6? How did you know it wasn't -6? It's a big number. A big number is going to have a positive exponent. If it's bigger than 1, that exponent is going to be positive. If it's smaller than 1, the exponent is going to be negative. Okay, so I'm going to want my decimal point to be right here. So I'm just going to count my jumps again. And I'm going to go 1, 2, so 7.9 times 10. And that's a 2, but I know that this number was initially less than 1, so it has to be negative. Okay, let's do it again. I want a number between 1 and 10, so I got to put my decimal between the 3 and the 5, and I'm going to count my jumps. 1, 2, 3, 4, 5, 6. So 3.54 times 10, positive or negative? Negative, it's smaller than 1. Negative, what did I say, 6 jumps? I lose track when I start chatting. It's a 6. Can y'all, is it big enough on the screen for those of y'all in the back? And you know, if it's ever too small, you know you can get on Zoom and you can see the screen that way too. That's a good, it's there. Okay, now we gotta go the other way. Express the numbers in decimal form. So for A, am I gonna end up with a number that is greater than 1 or less than 1? Less than 1. So I'm gonna make this decimal place jump 1, 2 times to give me a number less than 1, and then just fill in the gaps with zeros. And I like to put a 0 before the decimal as well, so 0.074. Okay. The next one, we're going to get a number that is greater than 1. So we're going to make it big. We're going to hop 1, 2, 3 times and put in an extra 0. So that's 3750. 3,750. Now our next one is negative. So we're going to go smaller, but we're going to go 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And that's where my decimal goes. So I'm going to fill in zeros. 1, 2, 3, 4, 5, 6, 7. So I gotta go 0.1, 2, 3, 4, 5, 6, 7, 1, 1, 9. Good? Do I have a question? Let's see. Do you have to worry about significant figures for these types of problems? You actually don't have to think about it, because you actually end up having the same number of significant figures. Writing it in scientific notation shows you how many significant figures you have. So if you were going to look at these, right, the decimal's present, so it's coming in here, so I only have 2, which is what we saw in the original. Here, the decimal's absent, so we're going to come in this way. We have 3, and that's what we had here. Decimal's present, so we're coming in this way. We have 3, and we started with 3. So you don't really have to worry about it, because scientific notation tells you that you have that many significant figures, right? Okay. Ooh. All right. I think, all right, 28. An asthma medication of 1.00 times 10 to the negative 8 grams. I'm going to tell you it's going to be really, really, really important. And I'm going to tell you to tag. I don't know why I put an E on that because I can't spell. When you're writing numbers, typically in chemistry, they're always going to have a unit. And sometimes they have even more than a unit. Sometimes it's grams of chlorine or milligrams of aspirin or whatever it is. So you're not only having to write a unit, but you also have to tell me what that is a unit of. So my tag is for you to remember to put as much information on your answer as you really need. So in this case, we're only going to express it in decimal form, but if this were like a math answer, you would have to tell me it's X number of grams of asthma medication or whatever it is. So just make sure that you know what you're doing as you do a lot of math. So -8, we're going to have a big number or a little number? Tiny number, right? We're going to move 1, and then we're going to keep jumping, right? What's that? 1, 2, 3, 4, 5, 6, 7, 8. And you'll notice that the number of zeros that you put in is, guess what? 1 less than what's here. So it kind of makes it easy. 0, and then 1, 2, 3, 4, 5, 6, 7, and a 1. Now, this is where you have to worry about the significant figures. Am I done? Why not? This is significant. These zeros are significant, so I need to put them in. And I need to make sure I put my units. Make sure you put in those zeros. They were significant zeros. That's the only case where you have to worry about significant figures. Vitamin D dose, we're going to do the same thing, and we're going to hop 6 times. 1, 2, 3, 4, 5, 6. All right? So our answer is going to be 1, 2, 3, 4, 5, 0 grams. So it's always going to be these zeros in front here, always going to be 1 less than what's here if it's a negative exponent. Okay. All right. Next one is to express the following numbers as a percent. And typically when you're asked for percents, we'll always tell you how many significant figures to give your answer to. Because sometimes with percents, it can be a little sketchy as to how many you should have. But how do we convert a decimal to a percent? What do we do? It's really easy. Multiply by 100 and you get the percent. Okay, so 58.58 is what? 58%. Make sure you put your percent sign. 0.36 is 36%. C, 12.5%. Now, what did they tell us though? 2 significant figures, so we should round this to 13%. Okay. Now we're going from percent to not a decimal, but a fraction. How are we going to do that? Just show it, because really, let me try a different color, right? 20 over 100. If you put it in a fraction form, what happens to these zeros? They just cancel, right? So then what's 2 over 10? Can we reduce that? 1 over 5, 1/5. How about 75%? 3/4, how'd you know that's so easy? Quarters, that's right, that's right. Okay, 40 over 100, right? Our zeros cancel, so 4 over 100, 4 over 10 reduces to 2/5. 12 over 100. What are you gonna do? Well, let's do it easy. Can we divide them both by 2? Sure, what's 12 divided by 2? 6 over 50. Could you reduce that any more? Yeah, they're both divisible by 2. Okay, so what do we get? 3 over 25. Are we as reduced as we can get? Yeah. So you could take multiple steps. You don't have to look at it and know the answer right away. Okay, determine the percent from the numbers given here. So when I read a sentence like this, I try to make myself a little math equation because that makes more sense to me than words. So 50 is equal to what percent of 125? I'm gonna learn this, y'all. I really am. 125. Okay, so now what? Yeah, so I get rid of the decimal and I make that over 100 because that's what a percent really is, right? So how do I solve for x? Yeah, so you could do it any which way you want, but if you want to put 125 on the bottom, you want to put 100 on the top, and whatever you do to one side, you have to do to the other. So 100 over 125. So 100 times 50 divided by 125. What do you get? What do you get? Anybody? 40? 40%. That's right. Have confidence in yourselves. You can get this. You can do this. Okay, let's do another one. 6 is equal to what percent of 600? So what are we going to do? Change that decimal to 100, right? And then just flip-flop them. So 600 on the bottom, 100 on the top. I did not give myself enough room to do that, but I'm going to squeeze it in. 100, 600, right? So the 600 and the 100 cancel on this side. You're left with x. So you do 6 times 100 divided by 600. What do you get? 1%. Did y'all like my little tutorial on how to tip? Did y'all? Isn't that cool? That's awesome. That's how I always tip. I always tip at least 20%. So it's just a nice thing to do, unless they make me really, really unhappy. But I don't think I can ever remember tipping less than 20%. So you should do that because service workers get paid much less than what we think they do. So, all right, man, we're plowing along. How y'all doing? I feel like we need like a break. You need to stretch. You need to stand up and wiggle around a little bit. It's hard for me to stay in one place. This is difficult for me. I can't imagine sitting at the desk the whole time. If you need to get up and stretch, please do it. It's okay. Don't mind. All right. Based on your experience, is each of the following more or less dense than liquid water? More or less dense, what does that mean? If it's more dense, it's going to sink. If it's less dense, it's going to float. Right? So does a paperclip sink or float? It's more dense, right? So it's going to sink. So it's more dense. Table sugar? It's going to sink. If you stirred it around, it would eventually dissolve, but it will sink, so it is more. And how about ice? Okay, now y'all, this is like one of the coolest things on the planet. The solid form of this substance floats in the liquid form. No other substance on earth does this. That is how cool water is. Because in liquid form, the water molecules can move around any orientation that they want, right? They're really loosey-goosey, whatever. But when they're in the solid form, they're stuck. And so they form a crystal. So ice is actually a crystal, FYI, but it's very tightly arranged. And so it actually ends up being more spaced out in the solid form than it does in the liquid form. Only substance on Earth. It's so cool. All right, the things I think are cool, you probably don't. That's okay. All right, calculate the density in grams per milliliter of 2 liters of gasoline that weighs 1.32 kilograms. All right, so whenever we're looking at all these conversions, you have to know 2 things. Where do we want to go? And what are we starting with? So where do we want to go? We want to get our density in grams per milliliter. This is our goal. What are we given? 2 liters of gasoline, and we're told that it weighs 1.32 kilograms. So you could do this in a dimensional analysis, or you could plug it into the density formula. Either way is perfectly fine. So what you have to remember with density, what's the formula for density? The what? It's mass over volume. DMV. Do it in that, like you're going to the DMV? Do it in that order. Okay, but what are my units? Units are important. What are my units on mass? Grams. What are my units on volume? Milliliters. So you have to make sure that you get to the correct units when you do this, right? So if I just did this, my density, I'm going to put my mass is 1.32 kilograms over 2 liters. If I just divided that, what are my units? Kilograms per liter. Now, technically the math works out on this one, so I don't really like it so much as an example, because there are other problems where you do have to convert or you're going to get the wrong answer. So let's go ahead and convert. Hello, there we go. I talk to it like it would ever listen to me. So how do I convert kilograms to grams? I need to go kilograms on the bottom. I need to go grams on the top. How many grams in a kilogram? This is one you need to know. Kilogram means, kilo means 1,000. So there are 1,000 grams in 1 kilogram. Right? So that's, we're going to move it 1, 2, 3, 1, 3, 2, 0 grams. And then how about liters? If I want to get rid of liters and I want milliliters, how many milliliters in a liter? Again, 1,000 milliliters in 1 liter. So I would end up with 2,000 milliliters. I don't like it that it would work out if you did it without converting the units, but it would. So what do you get? What do you get? I got 6.6. Y'all get that? Now I'm going to tell you while you're sitting in class, if you just copy down what I do and you don't do it on your calculator, you're going to struggle when you get to the homework. So you need to have the calculator that you're going to use on your homework, on your exam next to you, and you need to put it into your calculator because that's a skill that you need to practice. Because if you're doing it in class and you're not getting the numbers that I'm getting, you can come up at the end of class and go, Dr. B, I was putting in my numbers and I wasn't getting the right answer. And it's probably just that you're pressing something incorrectly or didn't put a parenthesis or use something like that. And I can help you with that. But if you're at home, I can't just look at your calculator and tell you what you're doing wrong. Okay? So use your calculator, have it out in front of you. All right. What time is our class in? I don't know. One what? 1:20. Okay, so we still got time. We're good. We're good. I just get on the roll and don't even look at the time. All right. So the next thing that we talk about is specific gravity, right? What is specific gravity? What are we comparing the gravity of whatever the sample is, we're just going to call it a sample, over water, right? We're comparing the density of some sample over the density of water. So density of a sample over the density of water. So if we did this with the ocean, and we got an answer that's 1.025, what does that tell us? Is it more or less dense than tap water? If we're saying tap water is a density of 1. It's going to be more dense. Does that make sense? Does tap water have a lot of stuff in it? Hopefully not. Some fluorine for your teeth, but hopefully not too much. But ocean water is usually a lot of stuff in it, right? Like salt, that can change the density of the water. So that makes sense. That makes absolute sense. All right. Oh, these are some fun ones. Okay, so when we talk about temperature, we really need to switch to being metric. We really, as a country, need to switch and stop using English units. We're like the only ones, the only last holdouts. And there have been some really, really terrible things that have happened because people didn't know to convert units. Like I'll give you a quick little story. They sent a probe to Mars, right? Did y'all hear this? They sent a probe to Mars. And it was between, I believe it was Lockheed Martin and another European country that were collaborating, right? And so we were doing some calculations, they were doing some calculations, and then we had to put our data together in order to tell this probe how much fuel to burn. Well, we did ours in English, they did theirs in metric, and then we just put it together, but nobody converted. So they gave that thing so much fuel that it straight burned up into the atmosphere. Do you know how much of a waste of money that is? Because somebody didn't convert their units? Can we not just get on board with metric? So that's my side spiel. Besides how to actually do it. Okay, so Fahrenheit is, in my book, the big F, that's the F word. We don't use Fahrenheit. But that's what we're all used to, right? So, and here, fetal cord blood is stored at negative 112 degrees Fahrenheit. Ooh, terrible. It's just giving me the chills saying the F word. Calculate this temperature in Kelvin. How do we do that? How do we go from Fahrenheit to end up at Kelvin? We have to go to Celsius and then Celsius to Kelvin. So be careful with that. So how do we go from Fahrenheit to Kelvin? Did I put the formulas? This is a formula I would give you. I guess I didn't. So I have the formula here we were converting from Fahrenheit. No, we're converting from Celsius here to Fahrenheit, but we have to go the opposite direction. So, so you need to know degrees Celsius is equal to degrees Fahrenheit minus 32 degrees Fahrenheit times 1 degree Celsius over 1.8 degrees Fahrenheit. I will give you that formula. Don't memorize it, but know how to use it. Okay? So we need to plug in Fahrenheit. So to solve for degrees C, we have negative 112 Fahrenheit minus 32 Fahrenheit times 1 over 1.8 degrees Fahrenheit. Okay, so subtract your 2. And then divide by 1.8, and what do you get? So negative 112 minus 32 divided by 1.8. Negative 80 degrees Celsius. Now what, are we done? No, we're not done yet. We got to Celsius, but we've got to get to Kelvin. This one's easy. right? Kelvin is equal to our degrees Celsius plus 273. Okay, so if I want Kelvin, my degrees Celsius was minus 80. So I'm going to add 273. What do you get? 193. You put the unit Kelvin. All right. Now we talk about energy, and what was I kind of liked. I was sad that this one was an odd number that I did on the video, but this is really important to understand when we talk about our bodies. That everything that we eat is really stored chemical energy, and when we digest it, when we break it down, then we can use that energy that is released from the breakdown to do things, and that's kinetic. Okay, so this one is not really related to the body, but it's the same concept. So discuss the differences in the type of energy present as a child climbs to the top of the slide. So they're going to be climbing, stands at the top, and then slides down. Okay, so what do we have while the child's climbing? What's the kiddo doing? Kind of tricky. I'm not saying he's at the top. Tell me about the top. I bet you know the answers to the top. What kind of energy do we have there? Potential, right? Absolutely. We have lots of potential energy. That's like the guy on the bike sitting at the top of the hill going, oh yeah, this is going to be a fun ride. And he coasts down, right? So then what about the sliding down part? Kinetic or potential? That's kinetic. Okay, so now we got that. But what's happening as he's climbing? It's not just one answer. He's actually converting kinetic into potential. Yeah, sound good? All right, now we got to do some conversion factors. All right, a moderate walk burns 225 calories per hour. Talk to me about these calories. Are these energy calories? Or are these food nutritional calories? They're food or nutritional? Food, nutritional. How did you know that? It's a capital C. Whoever did that, I want to give them a little shake. Why did you name it the same thing, right? Okay, so that's what we're starting out with. Where do we want to know? We want to know number of joules burned. So this is our goal. So we're going to start out with 225 calories per 1 hour, right? Now what? We have to have a conversion factor, right? So if we're trying to go from nutritional calories to joules, we can't just go from the big C to joules. What do we have to go to? We have to go to the little c, and then we can get to joules. Okay, so how do we go? What's our conversion factor for this one? You would go and look that up, right? But in 1 nutritional calorie, there are 1,000 energy calories. And then how about this conversion? From energy calories to joules, you need to know that in 1 calorie, you have 4.184 joules. All right, squeeze that in there. All right, so we're gonna first go from nutritional we got to put the big C on the bottom. So we have in 1 nutritional calorie, we have 1,000 calories. I usually just put a big C so that I know that's the big C, because sometimes it's hard to tell if that's a capital C or a lowercase, but it's supposed to be lowercase. I've been monitoring my conversation, right? Oh, no, I went the wrong way. Okay. All right, so we're still good on those. All right. So then we're going to convert from calories. We want to put calories on the bottom, right? They're going to cancel out. And so we know in 1 calorie, we have 4.184 joules. So put into your calculator 225 times 1,000 times 4.184. What do you get? Nine zero? That's not what I got. I got 400. Double check. Okay. It happens. It happens. So what are my units on this? Joules, and that's right. I didn't lose my joules per hour. That's right. Okay. All right. Let's see. Okay, when we talked about the videos, specific heat. What has a higher specific heat, water or salt water, and support your answer? So when you look at a table in your book, your water has a specific heat capacity. Anybody remember? Well, it's calories per grams degrees Celsius, right? And so water is a specific heat of just 1 calorie, if we're going to talk about calories, right? So why would salt water have a higher or a lower specific heat? What is specific heat? Calorie is energy, gram is mass, and degrees Celsius is temperature. So it's the energy required to raise 1 gram, 1 degree Celsius. So is it going to take more energy to heat water, or is it going to take more energy to heat salt water? Salt water actually has a lower specific heat capacity. So the reason that we're 70, remember last time we said we were 70% water, right? Why do you want to be 70% water? Water has a really high specific heat capacity. So when we step outside in that hot Louisiana sun, it takes a lot of energy to heat the water in our bodies, which basically keeps us at a nice homeostasis. It keeps us at a nice cool temperature, right? Because if we weren't 70% water and we stepped outside, our temperature, our core body temperature would rise drastically. We would go into probably a coma, die, right? So we want to be made out of water as much as possible because it takes so much energy to heat water. So when you add things to water, you're actually going to lower the specific heat capacity. So the more water you put in, the better off you are at maintaining one particular temperature. Sodium what? It isn't as dense. That's true. That's true. Okay. All right. Is this our last? Oh no, we got one more section after this. We're almost done. Indicate if each of the following describes a solid, a liquid, or a gas. Definite volume takes the shape of the container. Definite volume must be a liquid. Particles in this state of matter are so far apart they do not interact. Gas, they do not interact very much. They do interact, but not a whole lot. Okay? All right. Well, this is a good one. All right. So this is something where you have to decide. You're going to be looking at data as clinicians, as scientists. You're going to be looking at data, and you need to know if it's good data or not. And to figure that out, you look at precision and you look at accuracy. So what is precision? So how close the numbers are to each other. So to each other. And what about accuracy? Accuracy is to whatever the goal is, right? So which set of measurements are more precise? Which ones are closer to each other? The graduated cylinder are much closer to one another. They only deviate by about 1 milliliter. Whereas over here, we're deviating by 4, right? So it's the graduated cylinder. What's more accurate? You actually end up, if you did the math, you would actually end up getting the same answer of 10 milliliters either way, but you have a smaller range. So I would even say the graduated cylinder again, right? So which measuring device for volume is more accurate? Do you want to measure with a graduated cylinder, or do you want to measure a volume with a beaker? I want the graduated cylinder, absolutely. A beaker is terrible for measuring volume. It's good for mixing, but terrible for volume. All right, we're gonna stop there. And how much do we have left? Ooh, the big hard ones. We'll do those, we'll do that last page on the very beginning of Tuesday. Okay? If you have any questions, come see me. Somebody need help with the calculator? Yep, I'll help you out. Okay. Anybody on Zoom have anything? Okay. I have 2 questions on here. Sig figs. 9. Oh, there was a sig fig. Which one was that had?
They were asking for sig figs.
Let's see. Keep going up. Keep going. This one. Oh, that's good. That's good. So there's only 3. This should be only 3 significant figures. So this should be 9, 4, 1. But don't forget your zeros. Yes. Good. Very nice. I'm happy now. Yay. Okay. I'm going to turn off my microphone. Will you be able to upload this Zoom recording when I go back to my office? So it might take a little while because it's big, but by, I don't know, 5 o'clock or so, it should be up, okay? All right, so I'm gonna end it so that it actually records, unless y'all have something else. Great, thanks. Okay, if you need something, send me an email. Okay, wait, I think I just stopped, what did I do though? I didn't end it.